So today we want to talk about topographic maps and satellite images. So when we talk about a topographic map, we're talking about how do we view landforms, right? So a topographic map is a two-dimensional model of the Earth's surface. So take a three-dimensional landform, like a mountain, and turn it into a two-dimensional object. So they are also sometimes referred to as contour maps because we're going to talk in just a moment about contour lines. So the contour could refer to the shape of something. We're going to be looking at elevation. Remember, elevation means distance above sea level, and it's represented by what we call a contour line. So when we look at a map, what we're really looking at are landforms. So let's keep in mind that those landforms could be hills, mountains, valleys, depressions like a crater. Okay, we're going to be looking at rivers. All of that can be represented on a topographic map. So when we talk about the map, in order to be able to read the map, we look at what are called the contour lines. Now the contour lines represent a value of elevation, or like I said, distance above sea level. So wherever I'm at on one line, that means I'm at the same elevation. So the value for any contour line is only going to be one value. So if I look on here, those values are going to be the same. So if I'm on this line, no matter where I'm at 800 elevation. This line indicates 700. Now, sometimes we have to think about how these maps are constructed. One of the rules when constructing the map is that your contour lines never cross. So let's think about this logically. I can't be standing at two different elevations at one moment in time. My foot is only at one elevation, so I could only be on one contour line. Contour lines do form closed loops or circles because they go around the entire landform. Sometimes they shift off the map, but it still would come back on in a different location and be closed. If you see a bend in the line, you see how it kind of makes a V. That V indicates that there is a river or valley or a stream. So when you're looking at, find the V, and that V is going to point uphill or upstream. The river is going to flow down. Another thing to look at is the spacing. So you see over here we have tightly spaced, right? So there's very little space between these contour lines. That indicates a steeper slope. You might see where they start getting more spaced out. You see the wider spacing in here. That wider spacing indicates a more gradual or gentle slope. So if we look here, this would be the landform. See how tightly packed the lines are here. Over in here, it's the steep mountain. And then down here, we have a flat area where it's wide open. Now, contour intervals represent the value of the space between each line. What is my change in elevation if I were to walk this path? So the contour interval on this particular map is 20. If this is 700 and this is 800, the difference between those two is 100. And there's 1, 2, 3, 4, 5 spaces in between. So 100 divided by 5 gives me 20. So that means each of these lines is increasing by 20. So this is 700, 720, 740, 760, 780, and 800. If I work backwards, it's a decrease, still going by 20s. Usually the contour interval is given on the map, but if it's not, you need to be prepared to actually solve for it. Now let's look at an actual map and see if we can put this into practice. So on my map, I have some contour lines, right? So if I look, I have an index contour of 1,000, an index contour of 1,500, and several lines in between. So if I want to find the contour interval of this map, I have to take 1,500 minus 1,000, so it's 500. There's 1, 2, 3, 4, 5 spaces in between, so 500 divided by 5. My contour interval is 100. So this is 1,000, 1,100, 1,200, 1,300, 1,400, and then we get to 1,500. Now, let's look at that spacing we talked about. In this area at the top, you're going to see where it's tightly packed in here, kind of by B. This area is very little space in between, so this indicates that it is steep. But over here, we become much more spread out, much more widely spaced. So this is going to be a gentle or flat slope. Okay. So we can kind of envision this landform having a steep side here and a much more gentle slope here. Now another thing to look at is that bend. Remember we said there's a bend in the lines. So if I look right over here, and it even says Fish Creek, these lines are bending into that V shape. So there's my V. So what that indicates to me is that there is a river, or could be a valley. Now, my V is pointing this direction, so my river is going to flow this direction. It's the opposite direction. If this is upstream, river is flowing downstream. Now another thing to look at is a change in elevation. So let's take a look. If I were to go on a hike, right, and I wanted to hike from, let's go from position B to position C. So if I was at position B and I wanted to hike to position C. So we're going to go from B to C. What is my change in elevation? Right, so what is our change in elevation for that? So we first have to find the elevation. So let's find the elevation for B. If I trace it all the way around, here it comes, where it goes off the page, comes back. B is at 900. And elevation C is right here at 1500. So if I want to know my change in elevation as I hiked, I would subtract those two. So my overall change in elevation would be 600. Now I'm going to talk about a strange landform. Sometimes, instead of elevation increasing, elevation decreases in the form of like a crater or a depression. So we would have a contour line, and then we would have contour lines inside, just like others, okay? But my ones on the inside are going to have these strange little lines. Now these little lines that are pointing inward are called hatch marks. Hatch marks indicate a depression, or instead of an increase in elevation, it would be a decrease in elevation. So if this line has a value of 800, my first line of the depression also has a value of 800. Imagine going over the rim of the crater. But my second line is actually subtracting. So if I'm going by 100s, my second line has a value of 700. So it's decreasing. We don't see these that often, but just in case you see those strange hatch marks, that indicates a decrease in elevation. All right. Now the next thing I want to talk about are satellite images. Satellite images are just an aerial view from space of a landform. And we talked about erosion, and we need to talk about how erosion is represented in these images. So let's take a look. So the first one I want to look at is in South Padre. So you see here in South Padre, we have this channel. So this is an aerial view. The green is the water. Here's our land, right? You can kind of see the beach right along here. I want to talk specifically about this area right in here. What's happening, and you can kind of see it over here, is there's sand. This sand is flowing. Now that sand is going through here, and it's trying to travel through here to get back out to sea. What's happening in this area is the sand is building up, and it's making it so that the water becomes shallow in that area, and boats can't get through. So we have to do a process of what is called dredging to remove all that excess sand. So they drag that sand out, and then they take that sand and they bring it down here. Now, they fill in those beaches, and it actually makes the beach wider. So we can clean this out by dredging or dragging the sand and then putting it back on the beaches. Another example is this image here. Now, if I give you this image, stop and think, what do you even think this is? If I just look at it at a quick glance, it looks like I'm looking at waves. That's very misleading. This is actually a sand dune. Now, a sand dune is reshaped by wind. We know that. So be very careful anytime you see one of these images like this, because there will be a caption. Read the caption so you know what the image represents. Otherwise, you'll get the questions wrong. This is a picture of a crater. So just like we were looking at up here in our topographic map, here is a crater. Now, this crater is actually a depression. You see how it's going down. Think about how this crater is going to change over time. This edge, or the rim, is going to erode. When it erodes, it's going to get smaller. So we're looking at this edge right here. So as it erodes, it works its way down, right? So we're kind of like getting rid of this area, and then we're working our way down. So as it erodes, this is actually going to become shallower over time. You know, millions of years, it won't exist anymore because it will have eroded away. Another satellite image is a bay. So you're going to have like a rocky coastline area, and then we have a bay. I want you to think about how the waves are going to change this landscape. So when we look, if I were to give you some points, the waves are actually going to be striking mostly on this area, right? The waves will crash in there. This is the area that's probably going to erode the most from the waves. Inside the bay, this area is going to be more protected. There's going to be less erosion from the waves. Now, there'll still be erosion, right? But the waves crashing in are going to hit the points the most. So those are just some images that show how erosion can change the landscape. So if you take a look at the images, think about how it's going to change over time.